So today we'll be talking about the angle side case. Okay. Now this particular case of given information is a huge pain. Okay, because there's not so straightforward as pretty much all of the other problems we're going to have. It's not like you just plug stuff into a formula and you get your answer. There's going to be some decisions we have to make as far as like how we approach this case, depending on what kind of values are given, and I'll break all those down for you, and we'll even create like a little decision tree as far as like what you need to check, and if this happens, then you do this, and all that kind of stuff. So in this case, what is typically given is some angle. So we've got like, I'm just going to use a dotted line because the third side is not given, but we've got some angle which is given. We'll call that theta for now. It'll usually be like A, B, or C, but just for now, we'll just know that this is the given angle. And then this side will be given. Okay, we'll call this the adjacent side. It's adjacent to the given angle. And then you're also given some other side length. So this other side we'll call the opposite side. Now, obviously, context matters here. We're not talking about right triangles. So all your SOHCAHTOA and Pythagorean theorem stuff is not really going to apply explicitly here. Now, I purposefully did not join this with the third side because sometimes it won't. Okay, sometimes it does, sometimes it doesn't. Depends on how big these things are. There's one other thing that we have to be able to calculate here, and that is the height of the triangle. And this is going to come into play as far as our decision making. So the height of the triangle, which is like this length right here, I'm going to label this H. This is the height. Make that a little bit more obvious. There we go. Now, looking at this diagram, knowing that you have this angle measure, these two sides, this height does form a right angle with the side that's not given. That would be one of the sides you'd have to find. How could I calculate the height? Now, the height is perpendicular to this, so we do have some right angle stuff that we can work with. Right? So with this is our given information. How do we calculate the height? Okay, so sine of theta, that's part of it. Right, because sine of theta will actually be like opposite over hypotenuse here. So this would be like the height over the adjacent side. So if we're solving for the height, we would need to multiply both sides by the adjacent side. So you have this adjacent side is like whatever that given value is, the side that's next to the angle measured, not across from it, so not opposite, but right next to it, times the sine of the given angle. Okay? So we'll need that value to calculate all the missing information. There are a total of 4 cases here as far as like what can happen. So four distinct possibilities here, and we'll just sort of strategically go through each one. So let's go through. Let's talk about case 1. So case 1 is where now case 1 is where the adjacent side. I'm sorry, not the adjacent side. The opposite side, the side that is opposite of the given angle, is equal to the height. Okay? Now, in this case, so let's say we have a triangle where angle A is given as 25 degrees, side B is 6, So if I'm sketching this out, here's A, here's side B, and then this opposite side, what would that have to be if it was equal to the height, by the way? Well, what would it have to be exactly? How do we calculate the height? Yeah, 6 times sine of 25. So we'll just say it's exactly that, right? So it's exactly the height. Okay, if this is your case, then you actually have the easiest case of them all. Because if the opposite side is the height, then what kind of triangle do you have? A right triangle. So this isn't an oblique triangle at all. And if we have a right triangle, we have a plethora of tools to deal with this. We could use Pythagorean theorem to find the missing side. And we already know 2 of the angles, because this would have to be a right angle. And so we could subtract from 180 to get this. Okay, so in this kind of situation, you'll use Pythagorean theorem to find the missing side. And to find the missing angle, we have some options here. You could use SOHCAHTOA, or you could just subtract from 180. So subtract angles from 180 to find the missing angle. Okay, so I'm not actually going to work this one out. I just want to give you a guideline as far as how you would solve it. Okay, so there's no tricks. You don't have to use law of sines or anything new, as long as you recognize that if this is the height, then you have a right triangle. And so you can use all the old right triangle tricks to do that. How many solutions do you think there are here? Like how many? Well, we'll come back to that. Let's pause on that. Okay, so let's talk about case 2, where the opposite side is shorter than the height. So I'm going to use kind of the same numbers here as much as I can, so you can compare the different cases a little bit, you know, make it more of an apples to apples comparison. So I'm going to say, let's let angle A be 25 degrees. We'll fix that, and we'll fix side B. So what would be an example of a number that the side opposite of the given angle could be? Like, you know, what would be something smaller than the, well, what is the height here? Let's see, 6 times sine of 25 would be about 0.8. Is that right? Hold up here. Oh yeah, I'm like, that doesn't sound right at all. Oh yeah, so 6, oh, come on. 6 times the sine of 25. Okay, that sounds a little better. So it's about 2.5, right? So what would be a number that would sort of fall into this category here? Like, what would be a number where that would be less than the height?
2.
Like 2? Okay, so we'll say that like this is 2. In other words, that side opposite of the given angle is shorter than the height. So try to visualize this. We've got this side is 6. So angle A is 25 degrees. We don't know anything about this side, so I'm just going to do like sort of a dotted line here. And then this side is shorter than the height. So if this is about 2.5, where would, you know, this is 2.5, about 2.5. If this side is 2, what's happening here?
You don't have a triangle.
You don't have a triangle, that's right. if this is 2, no matter which way you swing this, it's never going to hit this other side. There's going to be some sort of gap. The height is the shortest it could possibly be, because then it's hitting at a 90-degree angle measure. So it could be longer than that, and you have no problem. But if it's shorter than the height, then you say there's just no solution. There's no possible triangle where the opposite side of the given angle measure is shorter than the height. So there is no solution. So our case 3 here is going to be where the opposite side is longer than the height, okay? And that's actually going to be the same thing for case 4 as well. So I'm just going to write that down. But once you determine that the opposite side is greater than the height, then there's one other thing you've got to check for, and that is the opposite side greater than or less than the adjacent side that's given? All right, so if the opposite side is also bigger than the other given side, the adjacent side, then that'll be case 3, and in case 4, the opposite side is smaller, okay, than the adjacent side. So I want to try to sketch this out up on the board first before I put this on paper, just to kind of give you. So in the case where the opposite side is really long, it's bigger than the height, and it's also bigger than the adjacent given side. Let's go ahead and write down these. Let's see. So we've got, let's say angle A is still 25 degrees, side B is 6, and we'll say side A is something really big like 10 or bigger. What happens in this case, we've got this lower side, this unknown side. I'll just do a dotted line here because we don't really know how long that is. We know this is 25 degrees. We know this is 6. And then this other side, which is 10, has got to come like way out here. Okay. So in this case, there's just one solution. Right? There's just one possible triangle, and you simply just use law of sines to solve it. Okay, so you just set up your proportions. You've got a pair to work with here, right? So you can set up law of sines to find this other angle down here, and then go from there. Okay. However, if the side that's opposite of the given angle is shorter than the other given side, like let's say angle A was 25 degrees, side B is 6, and we'll say side A is like 5, just like what we talked about up on the board. Then you actually get 2 different solutions, and I'll explain how to get like the second solution, because I think that's kind of the hard part. The first solution will be pretty easy; you just use law of sines. But to get the second one, you will use law of sines, but there's like something else you have to do. So in this case, there will be 2 solutions, and you will use law of sines, and I'll show you an example of how this will all play out. But basically, if you've got this side right here, we don't know how long it is, B equals 6, A is 25, and then you've got this side length that's 5, there are 2 options where this side length of 5 could go. You could either have 5b right here, or 5 could be right here. right? Where the height is just sort of like splitting it down the middle. So there's two places where that extra side could go, which would result in two distinctly different triangles. All right, so before we do the examples, what I want to create with you is a little decision tree as far as like, okay, what am I given? What do I do? All right, so I think this will be helpful once you start getting triangles that are just sort of like all of the different options, and to try to figure out exactly what to do. If you're given an angle side or an angle side angle, this is what you got last time. You're just going to use law of sines. So there's nothing very interesting about those. All y'all got hundreds on the quiz. This is really easy, obviously. Okay, but if you get the angle side, you will use law of sines, but there's sort of a lot going on, right? There's 4 different cases. So I'm going to come back to this one. Okay, and that's the one that really needs the breakdown. If you get side angle side or side, both of those cases you'll use what's called the law of cosines. We don't know that yet. We'll learn that next time. Don't worry about that one. And then the angle case is just unsolvable. Okay, remember there's infinitely many solutions in that case. So let's focus on this one. If you get an angle side scenario, and that's going to happen in your homework for sure, the very first thing you need to find is the height. So first find the height. And then what you're going to do is compare the height to the opposite side, or the side that's opposite of the given angle measure. Okay? So when you're comparing two numbers, they can compare in one of 3 ways. Either the opposite side will be equal to the height, it'll be greater than, or it'll be less than. So that's where this is going to split up here. Again, either the opposite side will be equal to the height, the opposite side will be less than the height, or the opposite side will be greater than the height. So if it's equal, that is the case where we have the right triangle. Okay, so you can use everything you know about right triangles, Pythagorean theorem. Just make a note. Use your Pythagorean theorem: a squared plus b squared equals c squared. Wow, I didn't even draw this triangle as a right triangle. Let's see. Let's make that look a little nicer. And this one's pretty easy. You don't have to do any special tricks here. You could have solved that one, a long time ago. In this case, there's only one solution. There's only one possible outcome. Okay? Now, if the opposite side is less than the height, if it's shorter than the height, then what happens then? There's no solution. There's no triangle. There are no solutions. However, if the opposite side is longer than the height, then you have to check one more thing. Okay? So if this happens, I'm going to split this up into 2 options here. So either the opposite side will be greater than, or we'll throw an equal to as well. So greater than or equal to the adjacent side, or the opposite side is shorter than the adjacent side. And again, when I say opposite and adjacent, I'm referring to the given angle measure. So if it's greater than or equal to, you'll use law of sines. In fact, you'll use law of sines in both of these cases, but what you really need to know going into it is how many solutions to expect. If the opposite side is really long or equal to the adjacent side, then you're just going to have one solution. Otherwise, you'll have 2 solutions, and I want to show you how to actually solve one of those 2 solution cases. So this is your decision tree. I'm hoping you can now see why this case sort of deserves its own day. So there's a lot to think about here. So let's do an example of this one, okay? So let's say angle A is 58 degrees, side A is 4.5, and side B is 5. Okay, so I'm going to sketch this out. First thing we need to identify is what kind of scenario we even have. Like, is it angle, side, 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 or what? Well, if I'm given one angle and then two sides where the two sides do not surround the angle, in other words, one of the given sides is opposite of the given angle, then this is going to be your angle, side scenario. So here's angle A, and I'm just going to do like a little dotted line here. We don't know anything about that side. Here's 58 degrees. The adjacent side is 5. And this other one is 4.5. Now, I'm not really ready to claim that there are, how many solutions there are yet, because I don't know what the height is yet. I need to calculate that. But going through our decision-making process, the first thing to do, like I said before, is determine what scenario you have. The very first thing. So if I flip back at this, I'm saying, okay, which one of these 6 scenarios am I dealing with? And this is the angle, side scenario. What a pain. It's the worst one. So the second thing to do is figure out, okay, well, since I know that's the scenario I'm dealing with, let's find the height. So the height would be like this length right here. So we can calculate the height with that little formula that I gave you at the very beginning, which is the adjacent side times sine of the given angle. So 5 times sine of 58. And roughly, let's say to 1 decimal place, how does that measure? Okay, 4.2. Yeah. Okay, we've identified the height, so now let's compare it. How does the height compare to the opposite side? Which one's bigger? The opposite side, right? It's 4.5. It's bigger than the height. So that ensures us at least one solution, right? So since, what side is that? Side A? So side A is greater than the height. Okay, so going down my little decision tree, opposite side greater than the height. Now I need to compare it to the adjacent side. So which one is bigger, the adjacent side or the opposite side? The adjacent side, right? Side A is less than side B. So how many solutions are we going to have? 2 solutions. And yeah, I know you kind of already knew that going into it. Spoiler alert, but this is what you would need to go through for each of these angle, side problems. So now I know there are 2 solutions. So I can sort of mentally prepare to find both of them. So let's sort of sketch these out and get ready to solve them. So there's going to be 2 possible triangles here, so I'm going to sort of sketch them both out. One of them would be if this 4.5 is coming out this way. The other one is if the 4.5 is over here. Okay? So I'm going to sketch both of those out. So here's 5, 58. Here's A, B, and then this one's where it's coming in. So here's A is 4.5. So here's my solution 1. And then solution 2 would be where it's kind of going out. So it's going out this way. So here's 5, here's 4.5, here's angle A, 58 degrees, right? Okay, so we've got 3 things, and so we can use law of sines to find what? What are we going to find first with the law of sines? angle B, right? Because we know side A, angle A, and side B. Now, when I set that up initially, you don't really know which triangle you're solving, right? Like, I'm going to have two sets of answers here, right? What I need is angle B, angle C, side C for solution 1 and solution 2. But when I set that law of sines up, how am I supposed to know, like, which one's which? In other words, like, when I set this up, 4.5 over sine of 58 equals 5 of sine B. How do I know if that's going to be like this B or this B? And maybe you don't know up front. But once I get the angle measure, how are we going to determine which solution that is? Like, what is the difference between this B? Exactly, right? So if this ends up being an acute angle, then I'll know that I'm in solution 2. But if it's obtuse, I'm in solution 1. Now, it'll always be one of these two, and I'll explain once we get there, like, why that is. So you don't have to understand why that is if you just know, like, one of them's going to be acute, one of them's obtuse.
Think about it, like, wide. If it's a wide angle, if you're taking the inside root, and it's a small angle if you go the outside.
Right. So let's work this out. We got to cross multiply divide, but at least in the notes last time, one thing we didn't have was one where we're actually solving for an angle measure first. All right, so it's not that big a deal. Let me show you how that'll play out. So I cross multiply, I get sine of angle B equals 5 times sine of 58 over 4.5. Well, how am I going to solve for angle B here? How do I isolate B? If I have sine of an angle measure, I want to solve for that angle measure. How do I get rid of sine? Yeah, inverse, right? So B is going to be the inverse sine of all this. That's something you'll just throw in the calculator. Okay, so if I type in inverse sine of 5 sine 58 over 4.5, I get about 70.4. We'll just call it an even 70. So B is 70 degrees. So is that going to be solution 1 or solution 2? Solution 2, right? Because it's acute. Now here's the little trick. Like, you don't need to know this, but if you can put this together, you'll be at an advantage. This will always be an acute angle because you're taking the inverse sine of something. And going way back to like unit 2 or something, when we talked about the restrictions on inverse trig functions, right? Inverse sine is restricted to be between negative 90 and 90. So you're never going to get an obtuse angle out of that. So you'll always end up solving this triangle before this triangle. If you don't recognize that, it's not a big deal as long as you understand that one of them is going to be acute, one of them is obtuse. But just kind of know that going into it. Well, now that we know this side, we can solve for the rest, right? Like, we can get side C, angle C. How are we going to get angle C? Now that we know that this is part of solution 2, let's find C2. If we know 2 of the 3 angle measures, how do we get the third one? Subtract from 180. So we got 180 minus 70 minus 58. So I don't know what that is off the top of my head. Let's see. 180 minus 70 minus 58, 52 degrees. How am I going to find that last side? Use law of sines again. Yeah. Use law of sines again to get that last side. So let's knock that out. 4.5 over sine of 58 equals c over sine of 52. Now this is going to be a rounded answer, so this c might be a little off, but it's not that big a deal. We'll cross multiply and divide, so c is going to be 4.5 times the sine of 52 divided by the sine of 58. Again, this is something you'll put in your calculator. None of these are unit circle values. So I get about 4.2. All right, so we solved one of the two triangles. All right, so you have to be a little tricky or a little clever about solving the second one, because the law of sines is basically going to lock you into solving this one. What I want to do first, though, is let me try to draw both of these solutions sort of on top of each other. So here's solution 1, right? And here is the triangle number 2, right? Now, in both of these cases, this is a 5, this is 58. I don't really care so much about that at the moment. But what I know now is that this angle is what? What do I know about that angle? It's 70, right? So this angle right here is 70. And what I'm going to use that to find is this angle measure right here. Well, look closely at this diagram real quick. This side length is the same as this side length, which is 4.5. Right? This is 4.5 and this is 4.5. So if I look at this triangle right here, which is not any of the solutions that I'm looking for, what can you tell me about that triangle? It's isosceles, right? So if you have an isosceles triangle, what can you tell me about this angle measure right here? It's 70. Yeah, exactly. It's 70. So if this is 70 right here, that's exactly right. These two are going to be supplementary, so you can subtract from 180.
That takes me way back to geometry.
Good, good. So to find the other angle B, you will subtract the one you got from the original law of sines from 180. Oops, 180 minus the other one. Those will always be supplementary, and that's what's going to sort of kick off the rest of your solving process. So what is B2? I'm sorry, what is B1? The solution 1? So it's 180 minus 70, which is 110. So this is going to be 110. Now that you know, now we know 2 of the 3 angles in that other solution. So to find the third angle in that triangle, we're going to subtract from 180 again. Okay, so to find C1, we're going to do 180 minus 58 minus 110. That's going to be pretty small, and we should expect it to be pretty small. Look at that little angle measure there. I believe that's 12. So 12 degrees. How are we going to get that last side? Law of sines again. Now we've got almost everything except for the one side, so we can set up law of sines here. 4.5 over sine of 58 equals C1 over sine of 12 degrees. And we'll cross multiply, get our answer here. So C1 is going to be 4.5 times the sine of 12 over the sine of 58. So it should look something like this. And I get, should be pretty short, about 1.1. So these are your two solutions.